Hello students, welcome you to this video. In this video, we are going to start a new lesson, triangles. So it's a familiar term to you, right? You know there are different types of triangles based on their sides and based on their angles, right? Suppose if we take the sides, all the three sides are equal. First we look into the sides. Suppose a triangle is given in which all the three sides are equal. So ABC is a triangle. AB equal to BC equal to AC. All the three sides are equal. Then that triangle has a special name. What is that? Equilateral triangle, right? Suppose only two sides are equal. We are drawing a triangle in which two sides are equal. For example, ABC is a triangle in which AB equal to AC. AB equal to AC and it is not equal to BC. Only two sides are equal. Then it has a name. It is called isosceles triangle. And in some cases, all the three lengths are different. All the three sides are of different length. None of them is equal. So AB is not equal to BC, which is not equal to AC. All the three sides are of different measure. Then it is called scalene triangle. So based on the sides, we can classify the triangle into three, right? Equilateral triangle, all the three sides are equal. Isosceles triangle, two sides are equal, and scalene triangle, all the three sides are of different length. Now, based on their angles, one is acute angle triangle. What is acute angle? Acute angle means it is what? Less than 90, right? Less than 90 is called acute angle. See, I am taking a triangle here, ABC. Every angle, if you see, it is less than 90, right? It is less than 90. So each angle is less than 90. Then that triangle has a special name, acute angled triangle. Acute angled triangle. So what is acute angle triangle? Each angle, three angles are there. All the three angles are less than 90. Okay. So that is acute angle triangle. And the second one is obtuse angle triangle. What's the name of the next triangle? Obtuse angled triangle. You know what is obtuse angle? Obtuse angle means more than 90, right? More than 90. What is acute angle triangle? All the three angles are less than 90. Then what is obtuse angle triangle? Yes, you are thinking all the angles are more than 90. Is it possible? How many angles? Three angles. Each angle is more than 90 means suppose 100, 100, 90, it is 290, something like that, right? Is it possible? No. We studied angle sum property, right? In a triangle, if you add all the three angles, your answer must be what? 180. So if one angle is more than 90, then how can the other two, right? So total angle is 180 only. Even if one angle is 90, then the remaining is 90 only, right? So other two must be acute angles, okay? So only one of the angle is what? Above 90. Only one of the angle is an obtuse angle. Other angles are all acute angle only. Here, this angle B is obtuse angle, right? But other two are acute angle. Then only you will get a triangle. Suppose this is one obtuse angle. If I form one more obtuse angle, then you won't get a triangle at all, right? So acute angle triangle, all the angles are what? Less than 90. But obtuse angle triangle, one angle is obtuse. One angle is more than 90. And the last one, right angled triangle. You know what is right angle? 90 degree, right? If one of the angle is 90 degree, then that triangle we call it as what? Right angle triangle. One angle is 90. Other two together it is what? 90. Then only 180, right? So one angle is exactly 90 degree. Okay, so then that triangle we call it as what? Right angle triangle. So based on the angles, you can classify into 3 acute angle triangle. Each angle, all the 3 angles are less than 90. Obtuse angle triangle, one angle is more than 90. And right angle triangle, one angle is what? Equal to 90. And in this topic, we are going to study congruent triangles. Congruent triangles. What's the meaning of congruency? There are 2 things, congruent and similar. Similar means it looks like, that's all. Suppose you take a circle of radius 5 centimeter and you take another circle of radius say 2 centimeter. Both look similar, right? Both are circles only, same shape, but size different, right? So this is called similar only. They are not congruent. Congruent means same shape and same size. Suppose you take a circle of radius 5 centimeter, another circle also of radius what? 5 centimeter. Then you say that 2 circles are what? Congruent. If we keep one on the other, it covers exactly. Okay, so that we call it as congruent. That we call it as what? Congruent. Same shape and same size. That is called what? Congruent. Then if 2 triangles are congruent, then what can you say? So we are going to study in detail about congruent triangles. So congruence of triangles. See, I have taken 2 triangles here. ABC is one triangle and PQR is another triangle. Both are of the same shape and same size. So if we keep one on the other, it covers exactly. Just I copied and pasted, so it is exactly the same only. So here what can you say? Corresponding angles. First you look into the angles. Corresponding angles are equal. If I take angle A, which is the angle corresponding to A in the second triangle? It is P, right? So angle A equal to angle P. If I take angle B, it is equal to, what is the corresponding angle in the second triangle? It is Q, right? Angle B equal to angle Q. And if I take angle C, is equal to angle R, right? So angle C equal to angle R. Corresponding angles are equal. Now, what can you say about the sides? Corresponding sides are equal. Side AB is equal to, what is the corresponding side in the other one? PQ, right? So AB is equal to PQ. This BC equal to QR. And AC is equal to PR. AC is equal to PR. So if 2 triangles are congruent, what can you say? The corresponding angles are equal and the corresponding sides also equal. It is possible only in the case of congruent triangles. How to denote the 2 triangles are congruent? See, how can you denote the congruency? Triangle ABC is congruent to, this is a symbol, or even draw 3 lines, okay? Congruent to triangle PQR. Okay, so this is how, some brief introduction about congruent triangles. So now we look at this one. Incongruent triangle, this is the important property here. Incongruent triangles, corresponding parts. Corresponding parts means it may be corresponding angles or corresponding sides. Corresponding parts are equal and we write in short CPCT. So this term you remember, right? CPCT. So whenever we do the sum, if you are using that result, suppose 2 triangles are congruent, then you say these 2 sides are equal. What's the reason? No need to write the full theorem. So just you say by CPCT. What's the meaning of that CPCT? Corresponding parts of congruent triangles. Corresponding parts of congruent triangles. Okay. So CPCT for corresponding parts of congruent triangles. Okay. So that you remember CPCT. Now see what is the criteria for 2 triangles to be congruent. So if you know the measurements, okay, you can see the measurements, okay, the sides are all equal, the angles are equal, they are congruent, okay. But if you don't know all those things, you know only few things, then what is the minimum criteria to say the 2 triangles are congruent? So we have an axiom. You know the difference between axiom and theorem? In some other video I taught that, right? Axiom means we are accepting something without a proof. So it is universally accepted truth. Okay. So axiom is just we accept it. It is a universal truth. And theorem, we can prove it using these axioms. Okay. So theorem can be proved. Axiom is a accepted truth. Okay. So here this is an axiom. This is a criteria for congruent triangles. Please listen this one. SAS congruence rule. SAS congruence rule. SAS stands for stands for side. Side, angle, side. That only in short we write SAS, side, angle, side. Now listen what it is. Two triangles are congruent. Two triangles are congruent if, see the condition. So when can you say two triangles are congruent? Two triangles are congruent if two sides and the included angle of one triangle is equal to the sides and the included angle of the other triangle. So two sides and the included angle. So two, that is why SAS, two sides, and in between we write A. So two sides and the included angle, not some other angle. So suppose if I take a triangle here, if I take two sides, suppose AB equal to PQ. AB is equal to PQ. AB equal to PQ. And BC equal to QR. BC is equal to QR. Then BC equal to QR. Then you must have which angle? Two sides and the included angle. Here I am taking AB and BC. So which is the included angle? The angle formed by these two, AB and BC. What is that? Angle B, right? So angle B must be equal to angle Q. Angle B must be equal to angle Q. So this only we call it as side, two sides and the included angle, SAS. So this is called what? SAS congruence rule. SAS congruence rule. So it's important thing. So using this rule only, we are going to do a lot of theorems and sums. So you can say two triangles are congruent if this axiom satisfied. What is the axiom? Two sides and the included angle. Any two sides. Suppose I am taking AB and AC. If I take AB, AB equal to PQ, AC is equal to PR, then which angle you have to get? AB and AC, right? So then what is the included angle? A equal to P. You must get A equal to P. Angle A equal to angle P. Then only you can use this SAS axiom. Okay, so hope you understood. SAS congruence rule. This is the criteria to prove two triangles are what? Congruent. Now look at this some example. Look here. So you can see there are two lines AB and CD. The two lines AB and CD, they intersect at O. And here they said OA equal to OB, right? They marked here. OA and OB are equal. There are two triangles, okay? So in triangle OBC and triangle OAD. OB equal to OA, right? OB equal to OA. OB equal to OA. And another two also equal, right? OC equal to OD. OC equal to OD. So two sides we got it. So can you say the included angle? That also equal. What is the reason? Vertically opposite angles, right? Angle BOC. Angle BOC equal to angle AOD. So two sides and the included angle. So you can apply the axiom, right? What we studied. So what's the axiom we studied? SAS, right? So using that SAS congruence rule, you can say that two triangles are what? Congruent. Which triangles? OBC. Triangle OBC is congruent to triangle OAD. So by SAS congruence rule. So hope you understood. So once you prove that two triangles are congruent, you can say the other three also. Totally 6 results you have to get, right? So corresponding angles are equal, corresponding sides are equal. But here with these 3, you can say that two triangles are congruent. Then you can say the other things. For example, you can say this BC or CB is equal to AD. Why? Using what? CPCT, right? Corresponding parts of congruent triangles. So you can say the other lengths are equal, other angles equal, everything you can say. Now look at this one. AB is a line segment. AB is a line segment. You can see the diagram. AB is a line segment and L is its perpendicular bisector. Listen very carefully. L is its perpendicular bisector. And if a point P lies on L, you can see the point P. P lies on L. Show that P is equidistant from A and B. P is equidistant from A and B. Listen carefully. AB is a line segment. L is the perpendicular bisector. Perpendicular bisector. Two things, important thing you are getting from there. Perpendicular bisector. What's the meaning of that? L is perpendicular to AB means that two angles are 90, right? This angle is 90 and this angle also 90. And one more thing, not only perpendicular, bisector. What's the meaning of bisector? It bisects. It divides into two equal parts, right? So that means this AC equal to BC. AC equal to BC. What's the reason? Because C is the midpoint. The angles are equal. Which angle? Angle PCA equal to angle PCB. Each angle is equal to 90. What's the reason? Because L is perpendicular to AB. L is perpendicular to AB. And one more thing you can see. Can you say PC? Can you see PC? PC is in which triangle? First triangle or second triangle? PC is in both, right? It is a common wall like that. It's a common side. It is common for both the triangles. So PC equal to PC, you say it is common. Now please look here. So PC is common for both. AC equal to BC. So two sides. Then the included angle also equal 90. So two sides and the included angle. So by SAS. Congruence rule, these two triangles are congruent. Which two triangles? Triangle PCA is congruent to triangle PCB. Once the two triangles are congruent, by CPCT, corresponding parts of congruent triangles are equal. So you can say the other three are equal. Which three? Angle A equal to angle B. These two angles are equal. Which angles? APC. Angle APC equal to angle BPC. And these two lengths also equal. Which two lengths? AP or PA equal to PB. PA is equal to PB. All these three you can say using this CPCT. But what we need here, that alone we take. So what they asked to prove, the point P is equidistant from A and B. So I take only the third one, PA equal to BB. By CPCT, PA equal to PB, and you write the conclusion. Therefore, what they asked to prove, show that P is equidistant from A and B. So finally you say, therefore, P is equidistant from A and B. So hope you got some idea about this. Okay, now listen here. We studied one axiom. What is that axiom? SAS. SAS axiom we studied. What's the meaning of that? Two sides, right? Any two sides, this side and this side. Two sides are equal and the angle in between, right? So that also equal in two triangles. Then you can say the two triangles are congruent. So next I am going to teach one theorem. You know what is theorem? So we need the proof also. Okay, that's a very important theorem. The name is ASA. ASA congruency rule or congruency theorem. You can say in any form. State and prove. So the statement also important. ASA. By seeing this you can understand. ASA. A for angle, S for side, right? So angle, side, angle. In two triangles, suppose the two angles, this angle and this angle are equal, this angle and this angle are equal, two angles and the included side, that means this side are equal. Then we have to prove that two triangles are congruent. So to prove two triangles are congruent, you have to check SAS rule. So, okay, SAS means two sides and included angle. So, what do you have to prove here, one side is equal, okay. I'm taking one of the angle as included angle. Say this is the included angle. Then you have to prove these two sides are equal. If you're able to prove these two sides are equal, then two sides and the included angle by SAS axiom, you can say that two triangles are congruent. So next I'm going to teach that theorem. That's a very important theorem. So you have to understand properly. Once understood, you can do it very easily. If you start writing, it will come for 2 pages or even 3 pages. But try to understand. Once you understood, then very easily you can do that. So listen very carefully this theorem. Listen. Statement also you have to study. Question will be state and prove ASA congruence rule or ASA congruence theorem. So statement you have to study. Two triangles are congruent. Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of other triangle. So listen carefully how to do this. I'm taking two triangles ABC and DEF in which, see what is given here? Two angles. I'm taking angle B equal to angle E. I'm assuming angle B given angle B equal to angle E. Then another one, angle C equal to angle F. Angle C equal to angle F. And the included side, ASA, which side? BC equal to EF. So this is what given in the question. So we have to prove that two triangles are congruent. For this, it is enough to check SAS congruence rule. SAS, just now I said. So two sides and the included angle. So among these three, already two are equal. One side, BC and EF are equal. One angle B and angle E are equal. So only thing you have to prove now, this AB and DE are equal. Once you proved AB and DE are equal, it is not given. So we have to prove AB equal to DE. So to prove AB equal to DE, once you proved this, it is over. By SAS congruency rule, triangle ABC is congruent to triangle DEF. Hope you understood this. So our aim is to prove AB equal to DE, that's all. So don't worry about anything else. You look only that AB and DE. So AB and DE, how it can be? So sometimes both lengths may be equal. We have to prove they are equal. Sometimes automatically they are equal. Then nothing to prove that, right? Sometimes they may be equal or they may be different length. Different length means AB may be greater or AB may be smaller. So we compare only AB and DE. AB and DE, you come across three cases. One case, AB equal to DE. Another case, suppose AB is longer one, AB is greater than DE. Or another one, AB is less than DE. So in all the three cases, we are going to prove they are congruent. For that, it is enough to prove AB equal to DE. Now case 1 we take. What is case 1? AB equal to DE. When AB equal to DE, proof is over. Because to prove AB equal to DE, if we take AB equal to DE, everything is already there, right? AB equal to DE, angle B equal to angle E, BC equal to EF, because the last two given. So side, angle, side. So by SAS congruency rule. Okay, you can write that. I'll give the notes later. So now just try to understand. By SAS congruency rule, the two triangles are congruent. Okay, this is case 1, AB equal to DE. Now we take the second case. AB greater than DE. AB greater than DE. Case 2. When AB is greater than DE. Second case and third case almost similar. So once you understood one, other will be very easy. So please listen very carefully. So here also we have to prove AB equal to DE. Already B is equal to E. BC is equal to EF. Already BC equal to EF. Angle B equal to angle E. We have to get these two are equal. So one more thing already you know, angle C equal to angle F. That also we know. Angle C is equal to angle F. Now please listen here, how to prove this. How can you prove this AB and DE are equal? You have to get AB equal to what? DE. Now let us see. Now we are taking they are not equal. AB is greater. But we have to prove no, it cannot be possible. Both must be equal. So let us see how. So AB greater than DE. So which is smaller? DE is smaller. For example, DE is 5 and AB is 7. Okay, so AB is greater. So what I am going to do now, I measure this DE, suppose it is 5, take that 5, then you mark a point P here so that these two lengths are equal. Which two lengths? PB and DE are equal. Okay, so you measure DE and you mark a point P on AB such that the two lengths are equal. Okay, so now what we are getting now, PB equal to DE by our construction. Now I am joining this CP. Join this CP. Okay. So now we are getting a small triangle here. Which triangle? This triangle. Triangle PBC. Triangle PBC and triangle DEF. Can you say that two triangles are congruent? Look at this. By our construction, this length and this length are equal. Already here this side is equal and this angle is equal. So by A Is congruency, you can say the two triangles are what? Congruent. This small triangle and DEF are congruent. So what can you say? By CPCT, right? By CPCT, corresponding angles are equal. So we take only this angle. I'm taking this angle, angle PCB. This angle is equal to angle F because corresponding angles are equal, no? So we are not taking the big triangle ABC, we take the small triangle PBC, we proved it, they are congruent. So angle BCP equal to angle F, but angle C equal to angle F. That given in the question. Now we see these two, in both the cases the right sides are equal. Right sides are equal. Once the right sides are equal, the left sides also equal. So you can say these two are equal. Which two? Angle BCP equal to angle C. Angle BCP equal to angle C. Now look at the diagram. Only from the diagram we are going to conclude. BCP. See, where is BCP? BCP, this angle, right? This angle is equal to angle C. That means the full angle. How can these two be equal? This small angle BCP is equal to the big angle. So that is possible only if this line CP we drawn, no? The P must coincide with A. There should not be any portion left out here. So P must coincide with A, then only the two angles are equal. So if the two angles are equal, there should not be the line CP. CP should coincide with CA. Okay, so P must coincide with A. P must coincide with A. So PB and AB are equal. So PB and AB. PB and AB are equals. Okay. So earlier we have taken PB equal to DE. But now PB is same as what? AB. PB is same as what? AB. So you can say that AB and DE are equal. AB and DE are equal. That is what you have to prove, right? Now AB and DE are equal. Already the other sides are equal. So by A Is congruent rule, the two triangles are congruent. Only thing you have to prove, AB and DE are equal. We assume they are not equal. AB is greater than what? DE, we assumed. And we take a point P and we said only that length is equal to DE. PB is equal to DE, but now we proved P cannot be somewhere here. P must coincide with what? A. So AB and DE are equal. Now I'll explain the third case also so you can understand better. It is just a repetition of this only. Okay, so don't worry about that. You would have got at least some 80% you would have understood. Look at the third case, then you can understand better. Okay, then you go through the whole thing again. It will be easy for you. Case 3. The first case we assumed AB and DE are equal. In single step we finished. Second case we assume AB is greater. Now AB is smaller. AB is smaller than DE. Listen very carefully, almost similar to case 2 only. But already it is given in the question angle B equal to angle E, right? Angle B equal to angle E. BC equal to EF, and angle C equal to angle F, right? Angle C equal to angle F. So, but we have to prove AB equal to DE. Again, same thing. So, we have to prove AB equal to, if I get AB equal to DE with these three side, angle, side. By SA is congruency, you can say the two triangles are what? Congruent. So, remember, we have to prove AB equal to DE. But we assume they are not equal. AB is smaller. So, now AB is smaller, right? So, measure that AB. Now, measure this AB and mark a point here. Take that point as P. Now, these two lengths are equal, right? Now, we join here. This triangle and this triangle are congruent. Why? These two sides are equal. The base, these two sides are equal. And the included angle is equal. So, the two triangles are congruent. So, once the two triangles are congruent, corresponding angles are equal. Angle C is equal to, angle C is equal to, which angle? Only this angle. What's the name of this angle? EFP. Look these two. Look these two. The left sides are equal. Once the left sides are equal, you can say the right sides are also equal. So you can say angle EFP equal to angle F. See the diagram. Second diagram, EFP. Which is EFP? EFP is only this part. Equal to angle F means the full angle. This angle is equal to full angle. How it is possible? Nothing should be here. Nothing should be here. Means the P must coincide with what? D. P must coincide with D. So you know PE is equal to DE. PE is equal to DE. So PE equal to DE. Earlier we said AB equal to what? PE. AB is equal to PE. But now that PE is same as what? DE. So PE can be replaced by DE. So AB equal to DE, you got it again. That's all, very simple proof. But you have to write it, okay? So I'll teach the whole thing again. Please listen with proper steps. Listen. So yes, ASA congruency rule. The statement you have to study. Two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of other triangle. Okay, so now listen. So first you take two triangles ABC and DEF. You know there are three cases. So what is given? Angle B equal to angle E, angle C equal to angle F, BC equal to EF. So there are three cases. First case we assume AB is equal to what? DC. AB is equal to DE. AB equal to DE. So these two sides are equal, we are assuming. Then already you know these two sides are equal and this angle is equal. So by SA's congruency rule, the two triangles are congruent. First part is over. Second case, AB is greater. AB is greater than DE. See, AB is greater than DE. So what we assume, what we do here, measure this length, mark a point P. Now this length and this length are what? Equal. Already these two are equal and the included angle. So you know this small triangle, this triangle and this triangle are what? Congruent. So the corresponding angles are equal. So this angle equal to this angle. But already you know this full angle also equal. So you know these two angles are equal. The small angle and the full angle are equal. That is possible only if P coincide with what? A. It is possible. Only thing writing work, everything write properly. P coincide with A. So PB equal to AB. So P coincide with A means PB and AB are equal. So you are getting the result. And the third case, AB is smaller than D. AB is smaller than D. Right? Then you measure this length, mark a point here. So now you know these two lengths are equal. Already these two are equal and this angle is equal. The two triangles are congruent. Two triangles are congruent. So the corresponding angles, this angle equal to this angle. Only this one part only. But already angle C is equal to this full angle. So you know these two angles are equal. Possible only when P coincide with D. So PE equal to DE. So from that you are getting the result. Okay, so go through once again and write and practice. But more than that, you have to understand. If you understood properly, then you can do that. If you read step by step, it looks 2 pages or 3 pages, don't be afraid. It's a very simple thing. Try to understand the concept. You can do it very easily. So based on that, I'm going to teach sums in my next video.